Alright, welcome back everybody. In this video we're going to talk about reading box and whisker plots and how we do that. First we're going to start when we have a box and whisker plot. There's a lot of information that we can gather about the data set with which to answer questions. The first thing we can do when we have a box and whisker plot is we can easily identify the 5 key characteristics that are shown in the box and whisker plot. We can identify the minimum value in the data set, the first quartile, the median, the third quartile, and the maximum. And if you remember back when we talked about these 5 characteristics, we talked about how those measurements subdivide a data set. And so because of that, we can tell how much of the data lies in certain intervals. 25% of the data falls between the minimum and the first quartile, and 25% of the data falls between the first quartile and the median, and 25% of the data between the median and the third quartile, and 25% of the data between the third quartile and the maximum. So we can use that to help us answering questions when we're looking at box and whisker plots. So let's look at an example of this. The box and whisker plot below shows the math scores of 300 students on their SATs. We're going to use it to answer the following questions. So we see the box and whisker plot here, and remember, because of the way that box and whisker plots work, I want to use a pen here, not a highlighter. 25% of the data falls between the minimum and the first quartile, and another 25% of the data falls between, and another 25% of the data falls between the median and the third quartile, and another 25% of the data falls between the third quartile and the maximum. Alright, so let's answer these questions. First, what was the maximum score for any student? Okay, so the maximum score for any student, we go out here, we find the whisker that represents the maximum. And that sits right here at 800. And so the maximum score for any student in this group was 800. Next, the Part B asks us, what score did 50% of the students score above? So we're looking for the top 50% of the scores. So the top 25% of the scores are here. The next 25 are here. That's the top 50% are from the median and above. So we look at the median, and that's the score that 50% of the students scored above. Alright, the next question, about how many students scored more than 575? So we identify 575 on our box and whisker plot here. It's the third quartile, which means that 25% of the students scored above a 575. So if we want to know how many students, we don't want to know what percentage of the students, we want to know how many. Now we're going to use the probability that a student scored above 575 and use it to predict how many students scored more than 575. We'll take that probability and we'll multiply it by the number of students in the population. There are 300 students represented by this data set. And so we'll take 0.25 times 300, and we get that there are 75 students who scored above 575. Alright. When we have a double box and whisker plot, not only can we find all the information that we can on a single box and whisker plot for each of the data sets, but we can also use it to compare the important factors between the 2 box and whisker plots and do a comparison of what's going on in those 2 data sets. Let's look at a double box and whisker. The double box and whisker plot below shows the number of chicken barbecue fundraising tickets sold by 30 students from the junior class and 20 students from the senior class. Use it to answer the following questions. Part A. From which class did more students sell less than 5 tickets? Okay, so looking at these box and whisker plots, 5 students are right here. And if you look for the 12th graders, that data point is the first quartile. So 25% of 12th graders sold less than 5 tickets. Okay, now how many 12th graders are there? There are 20 students from the senior class. So if I take 0.25 times 20, that's how many students sold less than 5 tickets from the senior class. So for 12th grade, I can't write 12 for some reason. For 12th grade, there were 5 students that sold less than 5 tickets. For 11th grade, the value of 5 is the median. So 50% of the students in 11th grade sold less than 5 tickets. So we're going to take 0.5 times the 30 students in the class, and there are 15 11th graders who sold less than 5 tickets. So let's answer our question here. From which class did more students sell less than 5 tickets? Well, there were 5 12th graders, there were 15 11th graders, and so the answer to this question is 11th grade. All right. Part B, which class had a larger range in the number of tickets sold? And here we don't even really need to do any kind of calculation. We can see it right in the double box and whisker plot. The range of a data set is represented by the distance from the maximum to the minimum. So the range for the 12th graders goes from here to here, and the range for the 11th graders goes from there to there. Which of those intervals is wider? We don't even need to do any calculations. We can very easily see that the yellow highlighted range is a little bit bigger than the pink highlighted range, and so which class had a larger range in the number of tickets sold? This was again the 11th graders. Alright, that's the end of this video. A few techniques that we can use in reading box and whisker plots. The biggest thing is utilizing the idea that 25% of the data falls in between any of the marks on our box and whisker plots, and using that to help us figure out what's going on. Alright, that's the end of this video. See you guys next time, and have a great rest of your day.